morning. I'm Weekend Dakessian. I'm the sales manager for RMD Kwikform in California. This morning we're at the Slauson Avenue project with the Griffith Company. This is a unique application for a mega shore where we have to support an existing bridge that is being used to install some new railroad track.
RMD Kwikform North America designed a specialist shoring solution for the rehabilitation of the Slauson Avenue Bridge in Los Angeles. The solution, designed and applied by RMD Kwikform engineers, enabled both road and rail traffic to continue over and underneath the Slauson Avenue Bridge, while an additional rail line was added to the existing main line track. In order for an additional rail track to be added to the two already running underneath the Slauson Avenue Bridge, 2 of the 7 bents supporting it needed to be removed and replaced, all while the bridge was functioning normally. The existing train tracks ran underneath bents 6 and 7 supporting the bridge. However, as the main line tracks travel between them at an odd angle to the axis of the bridge, it was not possible to accommodate an additional track without replacing the existing bents. RMD Kwikform worked closely with Griffith's company to deliver an efficient, safe and cost-effective engineering solution for each bent. Bent 6 was made up of a steel pier cap beam, set on top of 2 concrete columns that were replaced. The megashore towers that supported the 2 52-foot-long header beams had to first be put into place before the columns could be removed. 8 megashore legs fitted with hydraulic units were put into place to support the weight of the bridge and traffic overhead. 2 layers of cribbage beams were additionally utilised to distribute the load of the bridge equally amongst the megashore towers, while the existing columns were used to cope with the lateral seismic forces also absorbed through the cribbing. After the new columns were repositioned and constructed, the 8 girders comprising the bridge were then raised to remove the original pier cap beam. A replacement pier cap beam was then put into place once bearing pads to mount it on were installed on the newly constructed columns. The bridge was then lowered into place onto the new pier cap beam. The next part of the project was the removal of the single large concrete column and pier cap from which bent 7 was constructed. This also entailed supporting the remaining bridge structure above whilst this process took place. All the materials used to comprise bent 7 had to be removed before the new footing column and the cantilever pier caps were constructed. This is why 2 separate temporary supports were required, one 28-foot to the left of the pier centre line and another 30-foot to the right. As an added complication to this already technically demanding project, the left-hand temporary support was required to extend over the existing active mainline rail tracks. This meant that 4 100-foot-long header beams were used to support the girders making up the bridge. In turn, the beams will be supported by 14 megashore legs fitted with hydraulic units. 8 legs positioned to the centre line of the bridge, while 4 legs set on a common footing were positioned under the southernmost bridge girder. Meanwhile, on the north side of the track, 2 megashore legs were positioned in order to provide additional support. To overcome the seismic lateral forces, RMD Kwikform's engineers devised a solution that involves attaching 4 megashore legs set at 45 degrees from vertical to the header beams and anchoring them to the footings. The right-hand temporary support was set up in much the same way as the left-hand support, with 7 60-foot-long header beams supported by 16 megashore towers arranged in a similar fashion. Devising a solution that involved keeping a bridge open while performing its regular duties while major rehabilitative work is being performed is no easy task, and RMD Kwikform was able to provide an efficient and effective means of achieving this goal.